Hey mathematicians, in previous lessons we have learned how to find the rate of change in a table, and we've learned that what you do is compare how much your x value changes compared to how much, I'm sorry, I just said that backwards. You're comparing how much your y variable changes to how much your x variable changes, right? Well, we can also find rate of change from a graph. That process just looks a little different. So you'll notice that we've now, in the directions, it says that we're being asked to calculate the slope. The slope is just another word for the rate of change. And typically you'll use rate of change when you're talking about a table, but we use slope when we're talking about a graph because it more relates to a graph, right? Like when you're thinking about the slope of a graph, you think about how high, like how steep it is. So rate of change is literally just another word for slope. So let's see how we would use it by calculating the slope of each line segment on this graph. So it asks us to start with AB, which means we're going to start with that little segment of the graph right here. And I'm going to zoom in so that we've got a little bit of a closer look. So again, slope is really the same as rate of change. And we know that rate of change is the same thing as the slope, and it's the ratio of two different values. It's the ratio of our change in our y values over the change in our x values. Well, now that we're talking about slope, we're gonna, once again, we mathematicians use 80 different ways of saying the same thing. We're now gonna say, instead of change in y, we're gonna call it rise. And our change in our x, we are going to call run. This is the algebra way of saying change in y over change in x. And I think once you see an example, it'll make sense why. So the rise in this particular graph, and again, we're looking at between these two coordinates right here. So rise means the same thing as our change in y. So the rise literally means the vertical distance between coordinate A and coordinate B. And then the run, which is our change in our x values, represents that horizontal change in the graph. So what you do, since you can see that there are no numbers along the graph, we're automatically going to assume that each of these little boxes represents 1. So to find the change in your y, which again is also known as the rise, we simply need to count. Now, this is what we're not going to count. We're not going to count the lines like 1, 2, 3, 4, because that doesn't represent the length of the line. What's going to represent the length of the line is counting these boxes. So the height, our change in our y value is, in this case, 3. And then what is our change in our x, otherwise known as the run? That is 2. So far we have our change in y and our change in x, which is 3 over 2. And the last thing we need to do is decide whether that line is increasing or decreasing, because if the line is increasing, it's going to be a positive 3 over 2. If the line is decreasing, it's going to be a negative. So remember that we read our graph moving from left to right. So if I look here where we start and we look at it going in that direction, this is increasing, right? So that means that this is going to be a positive 3 over 2. So therefore, the slope, also known as the rate of change of segment AB, is going to be positive 3 over 2. Okay, next it asks us to find the rate of change between points B and C. So I'm going to zoom back in here, and I'm going to repeat the same process that I did before. I'm going to find my rise and my run, my change in y versus my change in x. And you'll notice that this side is 6, and this side is 4. So 6 over 4 is going to be our rise over our run. It's still increasing. That line is still going up, so it's a positive 6 over 4. Although we're going to notice that 6 over 4 can be simplified, right? If we divide both of these by 2, you're going to see that we get 3 over 2, which makes sense because this line has a constant rate of change because it's linear. So it makes sense that we should be getting the same slope no matter whether we're using, no matter what 2 coordinates we use in order to find the slope. The only difference is that in a case like BC, if we use 2 coordinates that are farther away, we're going to end up with a fraction that needs to be simplified. If we choose 2 coordinates that are closer together, we're more likely to not have to simplify. But you should still get the same slope no matter what coordinates you use. So we know that segments AB and BC are both 3 over 2. So if we use that reasoning, we already know that that last segment, AC, that they ask us for is also going to be 3 over 2 because it's linear and it has a constant rate of change. But I want to show you something really quickly using AC. So using these 2 coordinates right here. Once again, I'm going to draw my rate of change, but you'll notice I drew this is called a slope triangle, is what I've been drawing so far. All these little triangles I've been drawing are called slope triangles. And this time I drew kind of like the triangle up instead of underneath the line. And I wanted to show you that no matter what, you're going to get the same answer. So I'm still going to get the same slope, even though I drew the triangle like above the line instead of below the line. Because see here, I'll get my rise of 9. I'm going to get my run of 6, 9 over 6. Both of those are divisible by 3. So that gets me 3 over 2. So doesn't matter whether my slope triangle was drawn underneath the line or over the line. And it doesn't matter which coordinates you use. As long as you've done your slope correctly, you should always end up with the same slope. So that takes us to our final point that was asked on the notes. If we put a point anywhere on this graph and we found the slope, what would the slope be? Well, the slope would be 3 over 2 because this is linear, and so the rate of change is constant. So no matter what, the rate of change is always going to be the same because, again, this is a linear function. So in the last example, I actually gave you the coordinates to use, but what do you do if it asks you for the slope and the coordinates are not actually given to you? Well, in this case, you're going to actually need to choose your own coordinates on the line. And you should choose points that hit in, the way I say it, is hit in a corner. So I'm going to zoom in here so you can see what I mean. So first, let me show you what not to choose. So like, for example, you don't want to choose the slope that falls between this spot and this spot, because notice they're kind of like, let me actually circle it. So they're like in the middle of the line. So that makes it hard to estimate exactly how long your rise and your run are. Instead, by what I mean in a corner, you want to choose 2 places just like this, where the line literally hits it exactly in a corner. So again, you don't want to choose like that. You don't want to choose, right? You want to choose, or that you don't want to choose. So you want them to be right in a corner. So then my change in my Y and my change in my X, my rise and my run, still works the same way. So my rise this time is 4. My run is 6, which simplifies to 2 over 3. And then notice that the graph this time, moving from left to right, the graph is decreasing. So that means that the slope is going to be a negative slope. So the slope of this line is negative 2 over 3. So the last type of slope from a graph we're going to see is the graph of any horizontal line, which we remember from our previous unit that if it's a horizontal line, it's just going to be a horizontal line that goes through the y-axis at whatever number they tell you it's going to be. So since the equation is y equals 4, it's going to go through the y-axis at 4. So how do we find the rise and the run? Well, the same way that we did before. So in this case, our rise is going to actually be 0 because there's no change from up and down, like it stays flat at the same amount. Our run, let me just say I'm going to choose, because I can choose any two coordinates that hit in a corner. So I'm going to choose those two and those two. So in this case, my run would be from here to here, which would be 10. Well, 0 divided by 10 is 0, which makes sense because it's a flat line. So it makes perfect sense that the slope is going to be 0. And I know this video is run a little bit longer than the ones we typically want to, so sorry about that, guys. Last example is the slope of a vertical line. Again, a review back from our previous unit. This is going to go through the x-axis at x equals 4, which is why it's the equation, x equals 4. And in order to find the rise and the run, I'm just going to choose two coordinates that hit in a corner. So I'm going to choose those two. Well, my rise in this case is going to be 4. And my run in this case is going to be 0 because there is no change from left to right. Now you would think that 4 divided by 0 would be 0, but it's actually not. There's a video I'm going to attach here that explains why you can't divide by 0. So that, because out here it's kind of outside of the scope, but you can't divide by 0. So whenever you end up with the slope of a vertical line, since you can't divide by 0, we use a special term for the slope, and that is the word undefined, which means we don't even have a number to describe this slope. So the slope for any horizontal line is going to be 0 because that's going to be flat, while the slope of a vertical line is going to be undefined.